So this is then the second video on Max7221 SPI, video number 2, how to connect even up to 8 7-segment displays. So I'm going to go back to the program. I've already explained that this, the command is actually 9. That's the data. Of course, that one says it's going to be a normal decoder, digit number 0 and digit number 2. Digit number 1 will be a special character. As I've said just before, well, in my previous video, execute, if I use the command 0A, that is all to do with the light intensity, and if I put the data, whatever data I put in, will actually determine the light intensity. As I've also said, in my hardware, I just connected this 10K, but for Proteus purposes, I must put something in there. Otherwise, nothing is working. Then, what we have to do is, let's have a look at command 0B. So command 0B, if I look here, as it says, command 0B is actually a scan limit. So this tells the device, if I put in the, again, in the upper byte, if I put B there, it's this one here, the scan limit, it tells you how many devices must be scanned. So in this specific case, I'm going to scan actually 3 digits, from digit 0, 1, and 2, but it's 3 in total. So what we have to look then is go further and look at the scan. Let me just show you what I mean by that. Yeah, here it is. So if I look at the scan limit, I'm going to display on digits 0, 1, and 2. And although it's 3 of them, I must put in the data section, I must put hex 2. So this is why in my program, I have placed hex 02. So if you've got 3, you must put 02 digits to display. So if you've got 8, there will be 07. It's always one less. Then there's another one, which is actually the command 0C. Let's look at the command 0C. And we will see by that specific command that it says, it's this one, it's a shutdown. So in other words, if I use in the command the upper byte the value of hex 0C, it can actually switch on the device, or this displays, or off the displays. So what we can do is just, the first byte will be hex 0C. The second byte, if you send zeros, it will switch off everything. And if you send 01, it will switch on everything. And then it is possible, in my program, I did not use this, but it is possible to do a display test. So you can add a section in your program where you push out a value of upper byte hex 0F. And what that will be doing is it's going to test all the bits in this in your array, or in your array of how many 7 segments you've used. So it will just test all the A bits, all the B bits, everything will be on at that specific moment. So you can do that test, although I haven't done it. So then, of course, if I want to display something on digit 0, the hex code is going to be hex 1, 01. If I want to display something on digit number 1, the hex code is going to be 02. So in my program, you will also see, because this is what I'm going to display. So if I put there hex 01, that is the command, it's going to display on digit 0. This one, where it's 2, it's going to display on digit 1. And this one, where it's 3, it's going to display on 02, etc. So, and what we put here is actually what will be displayed. So on digit 0, which is the command 01, I'm going to display this straightforward 02. So it will display a 2 on that digit. Let me just go to this one, first of all, to digits 2. That is basically going to show up on, well, digit number 2, but you have to use a value of hex 03. And if I put 04 here, it will display 4. So let me just go back on digit number 1, which was that middle digit here, which was this one sitting here. If I want to display something there, I'm going to go to a U, just to show you how it's done. In the data section, this is the way those data, the segments are actually arranged. Where this is the least significant bit and this is the most significant bit in the data section. So decimal point, in my case, I want this to be a 0. So just look at the U. If I want to create a U, A will be off, and this is why A is a 0. B will be on. This is what this one's sitting here, the segment. C will be on, D will be on, E will be on, F will be on, and G will be off. So if you look at this, it's going to be 0, 1, 1, 1, 1, 1, 0. And if I put this into a hex format, that's where the 3 is coming from. And if I put this also in a hex format, this is where the E is coming from. And this is where I get that 3 from, 3E rather, to display U on the middle digit, like in this specific case. And this is basically how it's done. So it is possible to also add a decimal point if you really want to. We can do that. I'm gonna add it to this video just now, and I'm gonna show you how I can add a decimal point, maybe using 4 different 7-segment displays. But yeah, so let me go over and show you that. As I've said, I'm going to carry on now in my second video, but now I'm going to do the following. I am going to make use of 4 displays, as you can see there. So what I've done in this example is I've actually connected an LM35 to measure the temperature. And I wanted to show you how I can also add the decimal point here, so that you can see fractions in this specific case also. So if I can just quickly go to my program again, the program that I've generated for this one, it is, well, I've added some variables. Maybe what I'm going to do is I'll just quickly again scan through the program so that you can look at the program on your own time. Okay, so that's the program. So I've just added some variables there. I've added some flags, which is just showing me if the ADC is busy converting, etc. So I've added an ADC vector, which is an interrupt, which is also added. So basically, I'm not going to dwell on this one because this is not my focus. So, but what I'm doing here is I'm measuring the ADC. I'm making use of a 1.1 volt reference voltage. And I'm reading the ADC after I've basically started the start of conversion process. And my scaling factor will be, in this case, 1100, because what I actually want to do is I am breaking it up in smaller, in more digits. But at the end of the day, I'm going to place where my cursor is sitting at this stage. This is where I am going to place a decimal point by only switching on the point and making use of these values. So yeah, let's have a look at this. Is exactly the same as previously. Here I am actually just setting up the ADC 0 to measure it. This is enabling the ADC, getting the clock frequency correct, and also the interrupts. But as you can see, because I've got now 4 displays, which is going to be used, I've got 4 ones there. So I'm not using a strange character in this specific instance. This is exactly the same as my first video. That is the only difference here is because now I'm scanning 4 7 segments. This is going to become a value of 3. This is still switching on the chip. And as you can see here, I believe I've also switched on the ADC to be running. Because it is running in any case. Yeah. So I want to show you this. So what I've done here is after I've measured the temperature, I would then go and basically break up the temperature that I've got. The maximum value that I have is 1100. And I'm breaking it up into 4 different digits. The one is the fraction after the comma. This is units just before the comma on the left-hand side of the comma, the tens, and the hundreds. So as you can see, this is straightforward. In the first digit 0, I'm placing the fractions. But what I need to do here, although in digit number 1, I want to display the units, that is correct. But I also have to display the decimal point. And this is why I'm ORing it here with hex 80. If you will remember, we had in the data section, the decimal point was the most significant. And if I OR that most significant bit, which is what I'm doing here, with the rest of units, I'm actually going to have a value of 8 and whatever is going to be the correct value. So from 0 to 9, of course. And this is the tens, and that's the hundreds. And once I've got that, as you can see, it's going to be running through these. It's going to measure the temperature. They measure the temperature. And after measuring the temperature, here the conversion is started in this specific instance here. So it will measure the temperature and display it the whole time. So if I go to my Proteus design, which has got the 4 now, as you can see, I can maybe zoom in a little bit and do this. As you can see, although it says here 49.0, it's not showing the fractions in between 49 and 50, but on my display, I can see the fraction at this stage. And as you can see, I've also added this decimal point here, and now you've got a beautiful, although it says 50 there, it's actually 50.3, and if you increase it and so forth, you can actually get a much closer or more accurate display on this 4 displays as we have it here. And this is how we would make use of the Max7221 to display whatever we want. It would be a nice exercise, maybe on the right-hand side or left-hand side somewhere, to add another display. And on that display, if the temperature goes above a certain value, you add an H, for instance. If it's in a certain range, a top and up, or a higher range and a lower point, you can have normal, like a small n, a lowercase n, or you can also add in, maybe if it's too low, you can add a capital letter L, for instance, as part of this design here. This is it. This is how you would make use of SPI to basically display up to 8 7-segment displays using only, if you look here, only 3 wires. Data out from the master, the clock, and the chip enable pin, basically. Thank you, people. Thank you for looking at my video, and there will be some more videos posted on other topics. Thank you. Goodbye.